Alright, so here we go. This is episode 2 of the Simple RPG in Unity. So, last time we finished making our scene here. That video should be available so you can get this scene made. And now we will begin on some scripting for the very first time. But first, we're going to organize some of what we got going on here. So we'll go ahead and create a folder for these textures, whatever textures you may have brought in. And all these except this, Control and deselect. Put that in there. And there we go. So we're going to go ahead and start by downloading a character model. And I am a big fan of this one right here. So it is Low Poly Fantasy Characters Lite. You can find this here on the Asset Store and just download and import that guy. Let's see what we have here. Animations, models, prefabs, scenes. We'll uncheck the scene. We're not going to need that. And don't think we'll need the skybox either. That should be good. Go ahead and import this thing. Yep. Alright, now that that is in there, we'll go back over to our scene. Find where that went. Fantasy Characters Lite. Here it is. We'll go right into the prefabs and let's take a look at these. Alright, so this is the main example 1 character, and we will drag this prefab in here. There we go. Looks good. And now we will go ahead and rename him to player. Alright, now our very first script here. So we'll go ahead and start by making a folder called scripts. I like to use an underscore scripts so that it will stay right on the top of our directory here. Awesome. Now we'll go create C# script, our very first script. We will name it, let's do movement. There we go. Double click that to open that in Visual Studio, and we are on our way here. Yeah, why not? Alright, let this load up. Alright, so for those of you just following along with this tutorial, I'm basically going to be making 2 different playlists. I'm going to be making this playlist, which is a complete start to finish follow along tutorial for a simple RPG, and then on top of that I'll be making a playlist that's going to have standalone videos of basic C# coding and scripting. So I will, once we implement a new feature or a new concept of coding in this tutorial, I won't necessarily go into a whole lot of detail on everything because I'm reserving some of that stuff for the other videos that we'll be doing. There will be little standalone videos. There's one on types and variables, one on methods. I'll probably do some along the lines of referencing other scripts in another script, getting get component, stuff like that you might see that we do here now. So if you don't understand some of the topics that we go through, don't worry if I haven't uploaded a particular video that goes in depth on those concepts or topics. I will very shortly. I'm not going to outpace, with this series, I'm not going to go too far into detail on certain things that I have not already mentioned in other tutorials and kind of went through an in-depth on some of those things. So let's get started here. Alright, go back to Unity, and the first thing that you need to understand about scripting any game objects in Unity is that the goal of the script is simply to edit, alter, or change something in the game engine. It sounds pretty obvious, but let's connect the dots here. So we have a player, and the goal for movement means changing the transform. Now the transform is a component on this game object, and basically at the end of the day the transform is information about the object in your 3D world space of the game. So it has a position, it's the most obvious one, where it's at. You see it moves along the Z when I move him, same with the X, same with the Y. Okay, so when we're scripting a character or any game object to move, as maybe run or walk, we're going to be moving him forward. Okay, so what we're going to do here is basically through scripting we're going to move that Z-axis. So we're going to move him forward, or basically his forward axis. So before we do that though, let's come back into the inspector. Let's find the camera. And I've already done it, but you're going to want to drag the camera on top of the player, and that is going to make the player the parent of the camera. And then while selecting camera, we'll go up to the transform, we'll find these little ellipses right here, reset. And that's going to put the camera directly with the player. Then we'll zoom in here, we'll drag this up, move this back just so we get that kind of third person perspective here. Alright, then we'll hit E to switch into the rotate tool and go down just a little bit. That will work for now. Alright, so let's go back to our script here. Now we're going to implement, as far as I know, the absolute simplest way to create character movement. We might stick with it, we might change it later, I'm not quite sure, but for now this is what we will do. So the first thing that we need to do is we need to access a component on our game object. We need to know what component we're working with, therefore when we do that we're able to modify it, change it. So what we're going to do is we're going to access the transform. Now remember that is this, so the transform stores the position, rotation, and scale. Now that we have the transform, we are going to call a method called translate. Now translate moves the transform in the direction and distance of translation. And I think technically this is going to be based on local space. So the XYZ, the local XYZ of the game object, we're going to move it in a direction across one of those axes. So let's do translate transform.translate, and we need to provide it a vector3. Now a vector3 used to confuse the heck out of me when I first started coding. It is a lot fancier sounding than it is. A vector3 is simply a 3-digit number or data type consisting of 3 numbers. And it translates into X, Y, and Z. So we have to create a new vector3, open parentheses again, and we will give it a 0, 0. So it wants a 3-numbered vector3 that correlates with an X, Y, and Z. So because we're trying to move him or translate him through his local Z axis, we are going to do it like this. We're going to say when we translate, when we modify the vector3, we don't want to modify the X, so it's always going to be given a 0. We don't want to modify the Y, that would bring him up and down. All we want to do is modify the Z. So we'll open another parentheses here, and in here we'll give it the expression that is called input. We need to call input first, static class input, get axis. Now there's 2 types of get axis. There's get axis and there's get axis raw. In short, get axis will give you the float value between 0 and 1 based on how hard you press on a joystick, etc. We're using a keyboard, so we're going to use get axis raw. All we want is whether it's in the direction or it's not in the direction. So we'll open this up and we have to tell it which axis that we want. So we want the vertical axis, just like that. Now we'll do that for now. And like I said, this is, if you haven't used this before, this is a very confusing looking statement possibly to you. But I'm not going to get too much into it. We'll have separate videos. This is basically called, it's called a few things going on here. There's a vector 3 that we're using. We're translating the transform. We're getting input from an axis and input axis. So there's 4 or 5 different topics in this one line. And we will have separate videos to kind of go over how axes work, what vector 3s are, etc. So for now, we'll just save that and go into project. Now you're going to have to click and drag and drop it on the player, just like that. I've already done it, so mine works. Now that your camera is sitting behind the player, you should be able to just hit play. And now when we hit, remember WASD are controller keys. When we hit W, we're going to go forward. Now this is very rough. This is the rough idea of what we want to do, but there's quite a few things wrong. First of all, he is not interacting with the physics of the ground whatsoever, and he's moving way too fast. So let's fix that. Alright, so one of the first things that we will need to do to get more realistic movement here is we'll go to our player. I've already added mine, but you want to hit add component and you want to hit nav mesh agent. So stick that on there, then we'll go to window, AI, navigation, open the navigation window, go to bake, hit bake, and now if you press play, we use that same movement. It's still a little crazy, but you can see he's actually reacting with the ground. So the way that you do that is you add that nav mesh agent, which interacts with the nav mesh, which you bake. And basically the nav mesh is just this. It kind of computes the whole terrain and decides which area is walkable and which area is not, and that walkable area will react with your nav mesh agent as long as it's on your game object. So there is that. Now let's go back to the script and see how we can improve this, make it a little more realistic. So the first thing that we also need to do is add the ability to rotate so that we can turn. And to do that, we will need to add a similar statement to this translate of moving back and forth. We'll need to do a similar one that will allow us to rotate. So here's this transform.rotate, taking in a vector 3, and our x will always be 0. Our y is going to be our input of the horizontal axis, and our z is going to be 0. Just to make sure this makes sense to you, if I go to my player and I go into scene view and I get rid of this, god damn it, close this. Alright, so now we have the player, and see where his axes are here. So his y is right through his body, right through his head here, and his z is his forward. So if you think about what we did, we translated in our script his forward and backward movement. We left the x and the y alone, and we only translated that movement through the z axis. Now what we're doing in rotate is we're rotating him, but we're only rotating him on the y axis. So he's rotating on this axis, which is basically imitating this movement. This is what we want. And since translate works in his local space, as soon as he rotates over here, his z-axis will always be his forward. Okay? Alright, so that's why we're doing that. Once we put the input in on the horizontal axis through the A and D keys, which would be your left and right, he will rotate and then of course move forward in whichever direction becomes his new forward. So let's save that, go back into Unity and hit play, and now you can see he can rotate and he can also move very fast, too fast, but we're getting there. So let's go back to our script here and see what we can do about that. So this update function runs every single frame, and depending on the computer, how good the computer is, that can be 60 frames per second, 200, 300 frames per second. So what happens is each and every frame, when my input get access raw returns a value of 1 because I'm pushing in the forward direction, every single frame it's going to add 1 to his z-axis and move him 1 forward, 1 forward. So every second, if we're working in 60 frames a second, he's going to move 60 paces forward, and that is not what we want. So we can fix that right now. So the way that we would do that is by coming in here and finding a way to modify what this statement returns so that it is basically a lower number and a stable number that doesn't go up and down with the frame rate and is not super fast. Now remember, I have a video, if I don't have it now I will have it very soon, that goes over methods and how they work, but basically this translate is going to take this data that it's given as arguments, and it's going to return the result of that. And so translate is going to decide how far we move per x, whether it's frame or over time or etc. So a way that we can slow him down and we can smooth it and make it stable is we can take the results of this and we can alter them. And the way that we'll do that is we'll go take the result of that, multiply it by speed, and then multiply that as well by time dot delta time. And now speed doesn't exist yet, so if we hit control and period is the shortcut, I can add a private float. So basically declare a float. But I think what we'll do is we'll keep this public for now. Public and private are access modifiers. They tell the program where, what, when, and how that variable will be accessible. And I'll have a video on that. I'm not going to go too much into it right now, but public is just, it can be accessed anywhere by anything. Not really good practice to use public variables like this or fields, but in this instance we will, just because we want to expose this in the inspector. So we'll leave the speed at 1 and you'll see why. We'll go back into the game here. We press play. See how that works. Okay. Well, that is not bad. Alright, let's try this again. I actually had my speed set in the inspector to 7. So to show the demonstration, if we set it to 1, it's not the way we want it. It's way too slow. But the beauty of publicly exposing a variable in the inspector is I can adjust the speed in real time and test it and see what we'd like to have it. So let's find a decent speed. We're going to be running, so it's probably a good run speed, 7. Alright, so now that we tested that out, we can go in here. We can change this to 7, so that's a good speed. And so that should be pretty straightforward. Speed's going to be set to 7. Now time.delta time basically smooths the value so that it stabilizes the value so that it remains constant and doesn't go up or down based on frame rate. So that's going to smooth it, but of course it's going to make us a heck of a lot slower in the process. So we use speed and we insert that in there to speed them up a little bit and give them a particular speed that we can edit. So that takes care of that. Alright, so the very last thing, now that I know what speed I want, I'm going to set this to private read only, which in short means that I cannot change the value of speed. This is what I want it to be. I'm not even thinking about implementing any sort of way to change the speed. I mean, that might happen later. You drink a consumable and your agility goes up, therefore your speed goes up, or you get hit with a frost spell and it affects your speed and slows you down. Those are things you can implement later on, but for now we're going to set this to private read only float of speed value 7. And that's pretty much it. I mean, this is bare bones basic movement. Not best practices, but this is an absolute beginner tutorial, so we're just going to make things work right now. We're going to make them very basic. Each time a new video in this series comes out that goes over something like this, I'm going to try my best to always accompany it with some separate videos that are strictly there to explain how the axes work, how the vector 3's work, how accessing different methods and classes in this sort of structured, nested, or encapsulated type of way here, so that you can kind of make sense of this. But for now, I mean, that's all you need for basic movement. You need a way to move forward and backwards, and you need a way to rotate. So that's all for now. See you in the next one.